Okay, I got a question about homework 2, problem 4. So the question, so this is the one where each person chooses a number between 0 and 5. If you choose the same number, you get that number times 100. However, if your number is exactly one less than your opponent's, then you will get your opponent's number times 100 plus a bonus 100, and your opponent will get nothing. So in any other case, both you get nothing. So the deal is that you both gain by doing the same number, but you gain even more by choosing a number one less than your opponent. Okay, so when I write down the game, I have this situation. So, like for example, if I choose 5 and you choose 5, we both get 500. However, if I choose 4 and you choose 5, then I undercut you, right? My number is exactly one less than yours, so I get your number, which is 5 times 100, 500, plus a bonus 100, so I get 600, and you get nothing. Okay, so again, each person wants to undercut the other person by exactly 1. Okay, so the question is asking, how do I look at this game by, how do I solve how to make a prediction using dominated strategies? Okay, so let's see, what do I do? So let's think about this. Let's see, does, for example, 0 dominate 1? Well, this is a tie. 200 is bigger than 100, but 0 is less than 300, so 0 does not dominate 1 strongly or weakly. 1 doesn't dominate 0 either, right, because 100 is less than 200. So if you look at this, what you realize is that 4 dominates 5 in the sense that this is a tie. So again, we're looking at these numbers for person 1. This is a tie, this is a tie, this is a tie. 400 is bigger than 0, and 600 is bigger than 500. So in other words, 4 weakly dominates 5, okay, because it makes sense, right? There's no situation in which choosing 5 is better than choosing 4. Choosing 4 is always at least as good as choosing 5. And the way to think about this is that there's no reason why you'd ever choose 5, right? Because the only way you win if you choose 5 is if the other person chooses 5. If the other person chooses 5, you'd be better off choosing 4, and you get even better, right? And also choosing 4 allows you to win in this case. So in other words, choosing 4 is always at least as good as choosing 5, and sometimes better. So the way we say that in game theory is to say that 4 weakly dominates 5. So we're going to cross that out. Like that. Okay, we'll do that. I guess what I'll do is write down like this. So 4 weakly dominates 5, I guess, for person 1. Okay. So let's think about person 2. Now, in the smaller game, I can look at now, consider now between 4 and 5, right? Now, this is a tie, this is a tie, this is a tie, this is a tie, and 400 is bigger than 0. So we now, in the smaller game, have, for 2 choosing 4, that weakly dominates choosing 5. So I'm going to get rid of that. So now 4 weakly dominates 5 for person 2. Okay. Okay, so now in the smaller game, I've eliminated this, and I'm eliminated this, and now looking at this now. 3 now weakly dominates 4, right? This is a tie, this is a tie, this is a tie. 300 is bigger than 0, and 5 is bigger than 400. So 3 is always at least as good as 4, and sometimes better. So this is my third little guy. Right? Now 3 weakly dominates 4. This is for person 1. Okay, and you realize there's a kind of a pattern now, right? Similarly now, for person 2, choosing 3 will weakly dominate choosing 4, right? This is a tie, 300 is bigger than 0, etc. Okay, so we can write 3 weakly dominates 4 for person 2, etc., etc. So we kind of do this thing right now. In the small game, 2 weakly dominates 3, right? 0. These are ties. 200 is bigger than 0. 400 is bigger than 300. Okay, that would be, I guess, our 5th one. Now, for 2, choosing 2 weakly dominates choosing 3. Right? Now, for choosing person 1, choosing 1 weakly dominates 2. This is a tie. 100 is bigger than 0. 300 is bigger than 200. And now, choosing 1 weakly dominates this. I think now then we have this. Okay, no, and then finally we're left with this. Okay. So, in this particular order of iterative elimination of dominated strategies, we predict that 1 will choose 0 and 2 will either choose 0 or 1. Okay. Had we done it another way, like for example, had we started with this one first, then maybe we'd have ended up with something different. So anyway, so the intuition here is that although both people gain by choosing a large number as possible, right? Each person wants to undercut the other. So I have no reason to choose 5 because choosing 4 will always be at least as good, right? Okay, so I'm never going to choose 5. I should always choose 4. 4 weakly dominates 5. Okay, so, but since you're going to choose 4, right? I know you're not going to choose 5. You're going to choose 4, so therefore I should choose 3, right? Given that you're going to choose 4, so you're never going to choose 5. You're going to choose 4 or less. I should never choose 4. I should choose 3 for the same reason, right? Given that if you never choose 5, 4 is never going to be a great answer, right? Because 4, choosing 3 is always at least as good as choosing 4, right? Given that you're choosing 4, I should choose 3. Given that I choose 3, you should choose 2, etc., etc., etc. So it kind of unwraps all the way down. So we both end up releasing the DVD or choosing really low numbers, even though that is bad for us kind of as a whole. Okay, so that's how you would solve it using iterative elimination of dominated strategies. In this case, we eliminated weakly dominated strategies. Okay, so how about Nash equilibrium? That's the second part of the question. So we erase stuff. Okay, so Nash equilibrium is when you do the stars and pluses. Okay, so let's do that. Okay, so we do the stars for 1. So the stars indicate 1's best response. So if 2 chooses 0, what's 1's best response? What are the biggest numbers for person 1? Well, 1 has a bunch of zeros. They all tie for first place, so we put the stars in this. Right? All of these are the best response if 2 chooses 0. If 2 chooses 1, what's the best response here? What's the biggest number? Well, the biggest number for 1 is this 200. Right? So if 2 chooses 1, 1's best response is to choose 0. If 2 chooses 2, what's 1's best response? The biggest number for 1 is this 300. 2 chooses 3, what's 1's best response? The biggest number is this. 2 chooses 4, the biggest number for 1 among these is the 500. Okay. 2 chooses 5, 1 should choose 4. 600 is the biggest number. Okay. So what we just wrote down is 1's best response. Now we're going to do 2's best response. If 1 chooses 0, what's 2's best response? Now 2 cares about this second number, which is the biggest one. Well, they're all tied for first place. So put the plus over there. If 1 chooses 1, then 2 chooses the biggest number among here. Okay, among her payoffs, the biggest one is this. Okay. If 1 chooses 2, then the biggest number is this 300. If 1 chooses 3, the biggest number is this 400 right here. Sort of makes sense, right? If 1 chooses 3, 2 should choose 2, right? And undercut 1, right? You always want to choose the number which is 1 less than what the other person does. Okay, if 1 chooses 4, then 2 should choose 3 because it gets that 500. If 1 chooses 5, then 2 should choose 4 and get the 600. Okay, maybe I can do that in color just to be more clear. So 1 stars will be 1's best response. And the pluses will be 2's best response. Okay, so then it's just a matter of looking at which outcomes have both the star and the plus. And it turns out it's going to be this one, and this one. And so these are my Nash equilibria. So I'd write it down this way. Nash equilibria are going to be, if I use my colors, 0, 0. That's this one, where both people choose 0. Another one is going to be 0, 1. That's this one, where 1 chooses 0 and 2 chooses 1. And finally we have 1, 0. This is where 1 chooses 1, 2 chooses 0. So we have these 3 Nash equilibria. Okay. All right.